In this video, we are going to learn how to solve systems of equations by graphing. What is a system of equations? Well, a system of linear equations is two or more linear equations that have the same variables. So, for example, y equals 2x plus 5 is an equation. And if I turn this into a system of equations, I could do that by saying, hey, 2x plus, well, I don't have to say 2x. I could have used whatever x, like 7x minus 4y equals 10. And that would make this a system of equations because it's more than one equation that use the same variables. X over here, x over there, and y. There you go. So how do you find the solution to a system? The solution to a system of linear equations is the ordered pair that makes all the equations in the system true. Now, what do I mean by ordered pair? It's the x and the y value. That would work for both. That would work for both equations. So we're going to solve the systems by graphing. So, number one, use the graph at the right to graph the following equations. Y equals 1/2 x plus 3 and y equals 2x. Well, let's go ahead and graph both of them. This first one and this second one. For the first one, let's find the slope. The slope is 1/2, right? And our y-intercept is 3. That's going to be our starting point. Let's take a look at equation 2. My slope is 2. Or 2 over 1, because rise 2, run 1. And my y-intercept, I have none, which means it is 0. Let's start by graphing the red one. Start at y-intercept of 3. 1 over 2 means we rise 1, run 2. So rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Run 2. And then I'm going to go backwards with that as well. And there is, hopefully I can draw a straight enough line. That looks pretty good. So, let's graph the second line. My y-intercept is 0, and my slope is 2. So rise 2, run 1. So rise 2, run 1. Rise 2, run 1. Oh, look at that. We found already our solution. Rise 2, run 1. I'm going to go ahead and keep graphing. Continue graphing this, though. Rise 2, run 1, rise 2, run 1, going backwards, so got a line that looks like this. So, you want to remember that all of these points are solutions to this equation, and all of these points are solutions to this equation. What is a point that would work for both equations? It would be this one right here. And what point is that? That point is, let's see, is 2 and 4. That point is 2, 4. So x is 2, y is 4 will work for both equations. Do the graph equations have any points in common? Yes, and it is at 2, 4. Check, use the space below to prove that the point is a solution to both equations. So what I'm going to do is I'm going to use my first equation, y equals 1/2 x plus 3. And I'm going to put in 2, 4, x for 2, 2 for x, and 4 for y, and see if this is true. Does 1/2 times 2 is just 1. So does 4 equal 1 plus 3? Yeah, it does, because 1 plus 3 is 4. So that is correct. Let's try this 0.24 for the blue equation, y equals 2x. So they said 4 equals 2 times 2. Yeah, that is correct. So that does work. So 0.24 is a solution for both equations. That's what this is saying. Number 2, using the problem above, describe in your own words how graphing equations can help you find the solution to a system of equations. Well, you graph both lines. then find the point, or points actually, because the two lines can intersect multiple times, where they intersect. You'll also find that sometimes they will not have points that they have in common. For example, if the lines are parallel. So you may have a solution, you may have many solutions, or infinite solutions, and you may have no solution as well. Because let's say I had two lines that are parallel, they don't touch each other, that means you have no solution to the system. Or if let's say a line just touches multiple times, then you would have many solutions. Or if they both are the same line, you'd have infinite many solutions. All right, let's look at these. Graph the equations below to find the solution to the system of equations. Then use the check step to prove that the solution works in both equations. Show all your work. Okay, I'm going to just do this. Mark off my blue equations for all of these. And then mark off my red equations. There we go. This is going to be my red line. My red line. Okay, let's start off. My first equation, my slope is -1/2. And my y-intercept is 3. For my next equation, or for my next line, there's no slope. The slope is 0. And the y-intercept is 5. How do I know the slope is 0? Well, because slope is always being multiplied with x, and there's nothing being multiplied with x, therefore it's 0. So let's graph the red line first. Start at 3. Rise over run is -1/2. So rise of -1, run 2. Rise, run, -1, 2, -1, 2. I'm going to carry that pattern backwards. Carry that pattern backwards as well. Okay, so hopefully I get a nice straight-ish line. That's pretty good. All right, let's graph my next one. So y-intercept of 5 and a slope of 0, which is you don't rise at all, but you just run forever. So there you go. Oh, look at that. We see the point of intersection right there. What is that point? That point looks like it is 3, -4, and 5. So that point is -4, 5. Let's see if that is a solution to both of them. So y equals -1/2 x plus 3. We said that y is 5. And we said x is -4 plus 3. Let's see. -1/2 times -4 is +2. 2 plus 3 is 5. Yep, that is true. 2 plus 3 is 5. That checks out. Let's try the blue equation, y equals 5. In this case, we are plugging in 5 for y. So does 5 equal 5? Yes, it does. It checks out for both of them. Let us do graph number 2. Our slope is 1/3. Our y-intercept is -2. For my blue line, our slope is -1, or -1/1, because rise over run. And then our y-intercept is +2. Let's do the red line first. Start at -2. Rise 1, run 3. Rise 1, run 3. Rise, can't go forward, but let's take it backwards. Run 3, rise 1, 3, rise 1. Can't finish it, so something like that. Let's go for my blue line. Start at 2. -1/1, so rise, run, rise, run, rise, run. Oh, there it is. Rise, run. There it is, there it is, there it is. Let's try to bring it back. Here we go. Let's see if I can get a decent... There it is, pretty decent line. What is that point right there? That point is, gosh, 1, 2, 3, -1, I believe. 3, -1. Let's check. My first equation, y equals 1/3 x minus 2. Y is -1. X is 3. So 1/3 times 3 is 1 minus 2. Does 1 minus 2 equal -1? It does. Let's try the blue one. Y equals -x plus 2. So y is -1 equals x is 3 plus 2. Does -3 plus 2 equal -1? It does. All right, let's do our third equation. My slope is, I have no idea what my slope is. You know why? Because it's not written in y equals mx plus b form, so I'm going to do some side work, and I'm going to do that side work up here, actually. So -6 x plus 2y equals -8. So remember, I need to get the y by itself on the left side, so get rid of the x, the -6x specifically, so plus 6x to both sides. They are not like terms, so I can't add 6x to the -8. I'm left with 2y equals 6x minus 8. And then get the y by itself, so divide by 2. That cancels that out. Leaves me with y. 6 divided by 2 and -8 divided by 2, that's 3x. And that is -4. So here is my actual equation. I'm going to write it over here. Y equals 3x minus 4. I mean, they're both your actual equation, but this is a better one. It's written in slope-intercept form, which makes it easy to graph. My slope is 3. My y-intercept is -4. Let's look at my next line. My slope, thankfully it's in the right form, is -2. Let's put that -2 over 1. My y-intercept is 6. And for my slope of 3 is 3 over 1. So let's go ahead and get started. -4 is my starting point. 3 over 1 is 1, 2, 3, rise 3, run 1, rise 3, run 1, rise 3, run 1, rise 3, run 1. Let's take that backwards. Go backwards 1. That's what that looks like. Let's do the blue line. Okay, a y-intercept of 6. 2, 3, 4, 5, 6. -2 over 1, rise -2, run 1, rise -2, run 1. Oh, there it is. 2 over 1, rise 2, run 1. So, there it is. And what is that point? That point over there is 2 and 2, I think. 0.22. Let's plug it into both equations. Now, which equation should I plug it in? The original or the modified? It really doesn't matter which one you plug it into. You should still get the same answer. So let's go ahead and plug it into the new equation because I've simplified it. I've kind of made it easier. Y is 2 equals 3 times 2 minus 4. That is 2. 6 minus 4, that is true. Let's go to your blue equation. Y equals -2x plus 6. So y, 2, equals -2 times 2 plus 6. That is -4 plus 6. Does that equal 2? It does. That checks out. All right, we got number 6 now. Slope is, we don't know. It's not in the right form. We need to get y by itself. So I'm going to do some side work over here. -x plus 4y equals -4. Let's get rid of the negative x by adding x to both sides. I cannot add x to that 4, that negative 4, because they're not like terms. That cancels. You're left with x minus 4, or negative 4 plus x. On the equal sign, that's 4y, positive 4y, so 4y. Divide by 4 now. That cancels. You're left with y equals x over 4, and then negative 4 divided by 4. That, x over 4 is basically, there's an invisible 1 here, right? 1 over 4x, that's just 1 over 4x, minus 4 over 4, which is 1. So my slope is 1 over 4. My y-intercept is negative 1. For my blue line, my slope is 1/2. My y-intercept is negative 2. Okay, let's graph. Red first. Start at negative 1. Rise 1, run 4. Rise 1, run 4. 3, 4. Go backwards with that one. 1, 2, 3, 4. Rise 1, 1, 2, 3, 4. There we go. So far, so good. And then let's graph the blue line. Start off at negative 2. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Oh, there it is. Rise 1, run 2. Rise 1, run 2. And bring that pattern backwards. 2. And 1, 1, 2. Excuse me. There you go. So what is the point of intersection? Right there. That is 4, 0. So let's check to see if that is true. With my red equation, it was y equals 1/4 x minus 1. So let's do y is 0 equals 1/4 x, 1/4 times 4 minus 1. Well, that is just 1/4 times 4 is 1. 1 minus 1 is 0. That is true. Let's try the next one. Y equals 1/2 x minus 2, so y is 0 equals 1/2 times 4 minus 2. 1/2 times 4 is 4 over 2. 4 over 2 is just 2. Minus 2, does that equal 0? Yes, it does. That is our solution. Now, let's take a look at a real-world problem. Parking garage A charges $3 per hour for parking, and parking garage B charges a fee of 2 plus 2 per hour for parking. So 3 per hour is parking garage A. And then let's do parking garage B. So let's look at the information. 3 per hour is a rate. It is going to be our slope. That's like 3 times the number of hours. So the total cost, y equals 3 times x. Parking garage B, now let me do that in red. Y equals 3x. Parking garage B is $2 plus 2 per hour. So 2 per hour is 2 times your hours plus $2, so that's 2 more. So y equals 2x plus 2. Let me write that in blue. That is not blue. Graph each equation. What is the solution to the system of equations based on the graph? And what does the solution mean to the context of the story? Well, let's graph it first. So, let's see. Our slope is 3, or 3 over 1. Our y-intercept is 0. And for our blue line, our slope is 2. Our y-intercept is also 2. Let's say 2 over 1 for our slope. So let's start off by graphing the red line. Start at 0, and it's 3 over 1. Rise 3, run 1. let's go backwards. Backwards 3, or down 3, run 1. There we go. So, all right. So remember, what does this red line mean? This red line is the cost of parking at the garage. So 1 hour is $3. 2 hours is how much? Well, if it's 3 per hour, it's 6. And 3 hours would be 9. You can't see it on the graph. Now, do the negative numbers make sense in this? No. Like, if you parked for -1 hours, you would pay -3, or you would get $3. Well, so, you know, negatives don't make sense in this story, but positives do. But yeah, 1 hour, $3. 2 hours, $6. Let's do the blue line. Our starting point is 2, our y-intercept is 2, and they say it's $2 for an hour, $2 plus $2 an hour, so rise 2, run 1, rise 2, run 1. Oh, look at that, our points intersect. Rise 2, run 1. Let's bring it backwards because we kind of have to. This is what our line looks like. And what does this blue line mean? Well, when you park for 0 hours, you still got to pay that $2 fee. But if you park for 1 hour, that's $2 plus the $2 per hour. That's 4. 2 hours is like 4 plus the $2, which is 6. 3 hours would be, $6 plus the 2, which would mean $8. So what does this point mean? Actually, I should probably answer the what's the solution of the equation. We didn't write it down yet. The solution is this one right here. It is 2 and 6. 2 comma 6. What does the 2, 6 mean? Well, remember, 2 is the x, 6 is the y. What does y mean? Well, the y in this case is how much you pay, because remember, 2 hours, $6. And the x is like the hours. So this is the hours parked. And y is the money paid. Total money for parking. So the solution, what does the solution mean? It means at 2 hours, it costs $6 for both places. For both parking garages. Now, what do you think it means when the blue line starts going off and the red line starts getting steeper? It means that at this point, it actually becomes cheaper to park at the blue lot because you want the number to be lower. So as time goes on, the blue lot's actually cheaper. After 2 hours, it costs the same, but after more than 2 hours, at 3 hours plus, the red one, or the garage A, is actually going to be a better deal. So, summarize today's lesson. This is how you solve a system of equations. What is a system of equations? It's 2 different equations with the same variables. And what is a solution? It's the point, if you graph them, it's the point in which they intersect. And what that means depends on what the situation is, depends on the story. So anyways, go ahead and try some problems on your own. Good luck.